Hello, this is Digital System TA, and now start Q&A. First, quiz 1 answer, quiz 2 answer, and quiz 3 answer, and last is using quotas. When you're using quotas, so how to use simulation, so I can help this too. Number 1 is get the simulation result, enter the answer in midterm format in Excel. So I can explain this: function 3, function 1, function 9, function 7, function 0, function 5. Each function, A go to function 3, and function 1, and A goes to function 0. And D, input D goes to the function 3, and function 9, and function 7. And C go to the function 1, function 9, and function 5. And last, B into the function 0, function 7, function 5. So we start to make a formulation. First, A So I can check its function. Function 3, function 1, function 9, function 7, function 0, function 5. So let me start. Function 3 is input A or D. Function 1 is A or C. And function 9, input C or D. And function 7, B or D. Function 0, A or B. And function 5, B or C. So each OR gate is connected by function 10. So let's check the function 10. All of these functions get AND gate. I can start function 0, 1, 3, 5, 7, 9. So start A or B, and A or C, and A or D, and B or C, and B or D, and C or D. So this netlist get this formulation. So we can find minterm. You can find the minterm. Just a minute. Formulation A or B, A or C, A or D, B or C, B or D, C or D. So we must find the minterm. Yes, minterm 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14, 15. When you're trying to run this formulation on your code, the waveform simulator get this result. So minterm 0 to 15, there's 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, and 0, 1, 1, 1. This is the final answer. Next. Quiz 2 answer. Get the simulation result. Enter the answer in minterm format in Excel. Submit a written code as a text file to get the corresponding simulation result. Find the number of essential prime implicants in the corresponding K-map, so Kano map. We go to this first. When you see this Kano map, each implicant got the number. So I can count and show you this. Minterm 0, minterm 1, minterm 2, minterm 3, like this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you just try to type this. But just keep this section. We got this part, the written code. So the Kano map gets squared as possible as large. So this square is prime implicant because let's get the first. This implicant. For implicant can this implicant, but it is not prime implicant. They can get this yellow square. This is the prime implicant. Same way, this is prime implicant. And this is prime implicant. But number 2-3 question is find the number of essential prime implicant. This essential prime implicant is like that. For square number 1, square number 2, square number 3, and square number 4. When you squared this implicant, the useless square exists, but essential prime implicant is that what is not useless square. So number 1 and 2 and 3 is essential prime implicant, but 4 is useless, so it is not essential prime implicant. So when you see this column map, the essential implicant number of essential implicant is 3. So this part is 3. So we can back to hyphen 2. We can get 2 formulation. I can show you each formulation can different result. So this is first formulation. I can get formulation, so this is not B and this is not D. So not B, not D, and is D and not A. So you can get not A, D, not A and D. And last, this part is not C and D, not C and D. And all of these aggregate to union, merge. So formulation completed. Now we must not AD, not B, not D, not C, and D. The remain is enter the answer in minterm format in Excel. We can find the minterm 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So first the formulation, get this minterm. So 0, 0, oh, no, not 0. It's actually 1, 1, 1, 1, 1. And 0, 1, 0, 1. 1, 1, 1, 0. And 0, 1, 0, 0. But this implicant is number 3 and implicant number 13 is actually don't care part. So this part and this part is don't care. some students type this answer 0 or don't care. This part is 0 or don't care. But it doesn't matter. When I get this condition, when I get to student to condition, it may be matter. But I don't give them, so which you type the 1 or 0 or don't care, so don't care exception, they can get not lose the point. But when you type the formulation like this, but this is not matter, but second formulation is get the problem. Second formulation. So this is the first formulation. Second formulation. Squared like this and squared like this. And squared like this. So this can be formulated like this. To formulation. This part is not A, D, or this part is not B and not D, or and this part is not C and not B. So the second question's answer is like this. Oh. But when you get this midterm, it can be problemed. So I can get this midterm like this: 1, 1, 1, 1, and 0, 1, 0, 1, and 1, 1, 1, 0, and 0, 1, no, 0, 0, 0, 0. Because this don't care, not selected, not covered by square. So this is 0. But this is 1. So this is the difference. But some students type this part. So this is don't care. This is don't care. But some students get this part typed 1. This is not solution. So every midterm got 1 point. So typed like this student lost 1 point. Then second formulation, essential prime number of essential prime implicant is 3. This. Why this square is essential prime implicant? Because this implicant. The last quiz is number 3. Look at the given equation and answer the following. Solve 1 for odd number students and 2 for even number students. So number 1, odd number students. Function D or A, D and A or B or C, not. That part is 1 or 2. First, find the expression that apply the Boolean algebra until you can no longer apply the Boolean algebra. Apply De Morgan only once. Submit text file. Second, enter the answer in Minton format in Excel. So, let's check the solution. Function. This is using this Boolean algebra. And using De Morgan. This equal x. So yes, like this. Some modified code like this. Okay, so I can get this formulation, but a lot of students they apply the different Boolean algebra, so they can get various formulation. So only the important thing is they can same midterm for this formulation, and they can get optimization formulation. This is the important part. So I was show this part and check this part. Enter the answer in midterm format in Excel. When you typed the formulation, to quotas, and you can get simulation result. So this is going to be midterm. The midterm is only one solution. So let's check this out. 1 1 1 0 and 1 0 1 0 and 1 0 1 0 and 1 0 1 0. This is not changeable, This is not various. This is the only the solution. Same as I told you, one midterm got a 1 point. Next, 2. For even-numbered students, same question. Find the expression that applied the Boolean algebra until you can no longer apply the Boolean algebra. Apply De Morgan only once, submit text file. Enter the answer in midterm format in Excel. So this is what I solved this problem. Like this, De Morgan is applied, and where it is? Oh, number 14. This part or this part. So let's check this formulation to here. B and C, or C and D, and where it is? So let's check this. Like this. So I can find it. So there is numbering, and this part is going to be number 3. And this part going to number 2. The final let's return to this here. B and C, C and D, and B, not D. So let's get the consensus theorem. So there it is. We can go into like this. So change. Good to see. Good to see like this. B, C. P. Oh. DB, not like this. Just 1 second. D, okay. DB, B, C, C. D. Okay. This is final formulation. So, and in the consensus theorem, this y and z is removed, so b and c is removed. Consensus theorem can explain the Boolean algebra, but when you type this like consensus theorem, this can be solution. So final formulation is like this, and we gotta remain this midterm part. Check this. It is final formulation, and when you type this consensus theorem, it is not lose your point. So let's back to midterm part. Midterm 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's start 0, 0, 0, 1 and 1, 0, 1, 1 and 0, 0, 0, 1 and 1, 0, 1, 1. So this is the second quiz midterm. As I told you, each midterm got 1 point. 1 point. If you got any question, so please email email to this, and when you want to meet me, come to this room. So finished when you solve the quiz to give your answer. So now this slide is quite tip. Let me explain. When you use the program, these quotas, you may hard to use simulation waveform. So I can give you another way to get easier way. So just follow me. When you type the code like this, and this code, we get this button to run, and this message get green is okay, but yellow is not okay. Please rerun, and when it is finished, you can click this new file button. a new box is up here, and you can click University Program VWF and click the OK. So this box is up here. So same start, this is wave 1. You can double click right white box and go to Node Finder and click the list and click right button and OK. So when you follow this way, you can see it like this. But your only way to make the simulation waveform, you must drag like this and click one, drag like this and click one, drag like this, drag like this, drag like this, over and over. It is so wasting time. So you just make once and go to File and Save, or Run Functional Simulation. This button is Run Functional Simulation. So this is the save window. You can type the name like this: 4 input, 1 output waveform file, and click the save. Now, if you have another 4 input, 1 output code, you can record the save setting. So click the file and open. So open window is appear. 4 input, 1 output waveform file. Click this file and open. Open file. The last you setting like this is up here. So you just click this button to run, and the result is up here. This is the wave 1, and wave 2 is more simpler. Wave 2 doesn't matter to not even only once drag like this. So follow me. Click the right white box, double click right white box, and insert node or buzzy window is up here, and click the node finder, and click the list, and click the right button, and this selected node is up here, and click the OK button. At first, you can see like this. Nothing is happened. But next slide, you click the top and click the bottom. When you push the shift button, and you can show like this, you can see like this, and the cursor upon that and right click. So select box is up here. Select box is up here and grouping menu. So upon that mouse cursor, open the cursor and group. Click the group. So this window is up here. You can type the name in this box. Don't touch the radix or this checkbox. Don't touch this. Just type name and OK, like this. Then this shape is up here. The default value is 040, and when you click this under arrow button, what is the input node is like this. And this is very important point. Cursor like this upon that here right box and right click. So the select box appear and up on the cursor on value. So this is change 1, change 0, change don't care, not, and count value is on the checkbox. So click this count value. And count value window is up here. Then let me explain each line. The radix binary, this contain decimal, ASCII, octal, but we only use binary, so this doesn't matter. Start value is 040, but you can change 0010, 0100 like this. You can always change like this. The increment by 1, you can change 2 or 3. If you change like this 2, this can be like this. The default value is 1, like this. And count type is binary. We always use binary, so gray code doesn't matter. Don't touch this. The count average, it means this point. Count every means when you start 18. This start 160. Then this part is 120. This part 100. This part 140. So count every means this position. So when you increase this value like 15 nanoseconds, it is going to larger. So every setting is okay. You can click OK button and this window is up here. Every count, the form can change like this. In both cases, it returns the same result. This is the way 1. This is way 2. Just you can check this part and check this part. This part is going to recursive, so you can only check this first frequency. So this is the end of slide, and I say again, when you get a question, please email right here. And when you visit my laboratory, room 508. So this will be end.